All right, we're gonna go ahead and get started. Did everybody get a handout? All right, and we're before we begin, just some administrative things. As far as the end of the semester is concerned, and I just had the windows up. This is supposed to be the final exam schedule. It's not really visible to students, but now as far as our class, our final exam was going to be a take-at-home exam, but according to the schedule, this exam is supposed to be, and this is crazy because this is just a Monday only class, but this is pretty much what's important. This right here, this is the end of the term dates and grades, and this is what they send the instructors. So April the 23rd would be the last day to withdraw. So if you want to withdraw, it's a W. March the 2nd, all grades are due by the close of business. So I have to turn the grades in before 5 o'clock or whatever. May the 2nd, the grades are going to be visible to you all on May the 5th. Since the grades are due on the 2nd, I don't like to push stuff like to the very last day. So on May the 1st, that is when all assignments will be due. And also the final exam. Okay, during the final exam, you can use your full notes just as with any other test. Just take all of that out. And this is the first by 11:59 p.m. And there is no password. I'm going to take that off. All right, so all assignments, you're going to see some changes, but for now, I'm just resetting the final exam. So all of the assignments and the final exam are due by midnight April, May the 1st. Just make sure. I don't know why this says May the 5th. All right. So for the final exam is to take at home. You don't have to report to campus. You don't have to use Honor. This is the same as the other test. You can use the full notes. All right. So today we're going to look at the last module in the course. And the notes that I passed out, it actually contains 3 sections instead of 1 section. That's why it's so thick. And the last section, I don't know if this is a good or a bad thing, but this is mainly a calculator type thing. All right, but before we begin with that calculator or anything, we're just going to take a look at just an introduction to the linear system of equations. All right, so a linear system of equations, it consists of 2 equations that are graphed on the same coordinate system. Right? System of two equations, and I'm just going to skip down through the notes a little bit. This is what a system of equation looks like. So notice for a system, you have two equations. To find the solution for like one equation, you would just isolate for you, depending upon what type of equation it is, you could solve a single equation. But for a system of equations, which could be two or more, the solution to a system is the intersection point of your two graphs. So there's only three possible solutions when you deal with two graphs. So like take a look at this first one. So let's say if you graph, it looks like there's only one line on this, but it actually is two. So if we graph one line, I'm going to call that line 1. So let's just say we graph line 1. And then let's say I graph line 2, and it produces the same exact line, right? One line hits on top of the other line. The solution to a system is just the point of intersection. So if you're taking one line and putting it on top of another line, they're going to intersect everywhere as you're putting one on top of the other. So the solution for this type is going to be called an infinite solution. Right? There's more than one solution because there's more than one intersection point. All right, so that's one type of example. Another type of solution is just a one solution. So notice here we graph line 1, right? That would be the red line. Then we would take an equation for line number 2 and we would graph that. Notice that when we graph these two lines, there is one intersection point. The coordinates for that intersection point is the solution. Right? So if I had to figure out the solution for this one, I would just simply write out the coordinates for this intersection point. Right? And there's only one intersection point, so there's only one solution. And the third type of scenario, let's say that we graph one line, right? Line 1, that's going to be the blue line. And then let's say we graph a second line, that's the red line. Notice that these two lines never intersect. So since they never intersect, this is a no solution. It's a no solution. All right, so in order to determine the solution of a system of linear equations, we basically graph, and the intersection point is the solution. All right, so this is the first example, and this is dealing with the system of linear equations. So here we're given a system. We're not given any equations just yet. We're just given graphs. And based on the two graphs, we have to determine the solution. So basically, the solution is going to be this intersection point. Right, so in order to find the solution, I really want to write out the ordered pairs for this point. Right, so remember, when we are figuring out ordered pairs, we're always going to start at the origin, and you always move left or right first, right? Because in your ordered pair format, you have your X, which is the left or the right movement, which you have to go first from your origin. And then it's the Y, which is the up or down. All right, so I'm at the origin. Please be mindful of your axes. This thing is not going by 1, 2, 3, 4, 5. This is actually going by twos, so just be careful. So I'm at the origin, I'm going to go over 2, and then it looks like I'm in the middle. So I'm going over 3 places to the right, so my x coordinate is 3, and then I'm going to go down 4 units. So the solution should be 3, -4. So pretty much just looking at the graph and pulling out the coordinates for the intersection. All right, for the next slide, I just pull up an AI overview. And here we're talking about a matrix or matrices. Okay. So I don't know if you ever heard of the word matrix before, but a matrix is just a rectangular array of numbers arranged in columns and rows. A matrix is denoted by its columns. There's a handout. By its rows and columns. Right, so a matrix is denoted by its rows and columns. Right, so whenever you talk about a matrix, you have to give what's called its dimensions. So when you're giving its dimensions, you're basically giving it its rows and its columns. Right? Now, here is an example of a matrix. So the matrices that we're going to be using are going to be the coefficients of our equation. I'll kind of explain that later. So taking a look at this matrix, how many rows does it have? Well, this thing has 1, 2, 3 rows. And how many columns does it have? It has 3 columns. We would denote this as a 3 by 3 matrix. You always have to put the number of rows first, and then the columns come second. So think about RC Cola, rows, then columns. So what we're going to do in order to solve these system of equations, we're going to convert the system of equations into a matrix. We're going to put the matrix into the calculator, and the calculator is going to pretty much do all the heavy lifting. All right, so here is an example. It says solve the following systems. If there is a single solution, answer in an ordered pair format. So notice we have X, Y, and sometimes you may have Z. And then other times you may have 4 variables. It all depends upon how many equations you're working with. If there are infinitely many solutions, we're going to write out the all real numbers, right? So it says answer using reduced fractions if necessary. So I want to convert this system of equations, and these are linear equations, right? Because for a linear equation, the variables should have no power past the first power. So this would be a linear equation in 2 variables, right? X and Y variable. The second equation is also linear. It has 2 variables, but each variable is raised to the first power. So we want to convert this system to a matrix. I'm going to just write some steps. Oops. So the first thing we're going to do is put the system in standard form. Anybody remember what standard form is? Standard form simply means when you put all your variables on one side of the equation, and then you put your constant on the other side. Right? So on the side over here, I'm gonna put if possible, because sometimes you use the steps and sometimes you don't. So I'm gonna just say if possible. Right? So it's like the first condition is satisfied. These two equations are in standard form, both the variables on one side, constant on the other. The second step is we want to convert the system to a matrix. So whenever we talk about a matrix, we have to denote it by the rows and columns. So how many rows do I have for my system? 2 rows, right? How many columns? I should have 3 columns, a column for X, a column for Y, and a column for what the equation is set equal to. So I'm going to convert this system into a 2 by 3 matrix. Because it's in standard form. I have 2 rows and 3 columns. So now I'm going to pull up the calculator. So here is the calculator. And above this X inverse key, you see matrx, which is short for matrix, and it's a yellow function. So I'm going to hit second and X inverse, which is matrix. So here's what it pops up. These are the names of the matrices. So we can actually store up to, looks like 10 matrices. I'm generally going to work with A and B. So we have math. If I scroll over to math, right, these are some of the math functions. I'm going to scroll over to edit. All right, so these are the steps to third thing. We're going to put the matrix into the calculator. So I hit second, and then it was matrix. Then if you want to put a matrix in your calculator, I'm going into the matrix function and I'm scrolling all the way over to edit, and I'm going to hit enter. Now your calculator may look a little bit different from mine. You may have some stuff in here. If so, we're going to overwrite it. All right, so let me put enter. So the first thing we want to do is we want to put in the dimensions, right? So it's a 2, and then I'm going to hit enter to lock it in. And notice once you put in your dimensions, your matrix should change. Right, so I put in 2 by 3. So notice I'm looking at 2 rows and 3 columns, and mine is showing all zeros. Now, if you have something inside of your matrix, we're going to overwrite those values. But you should see this matrix set up with 2 rows and 3 columns. Right? The next thing I'm going to do is I'm going to put in the coefficients. So this first column, I'm going to put in my coefficients for X. The second column, I'm going to put in the coefficients for Y. And the third column, I'm going to put in what our equation is equal to. Right? So this first equation is negative 5X I'm going to put in -5 in my X column. And then you want to hit enter. For my Y column, I'm going to put in 5. And that's equal to -5. Make sure you hit the negative and not the minus, okay? Because a minus is going to give you an error. So I hit enter. And then I'm going to put in my coefficients for that second equation. -1, -2, -7. All right, so just kind of looking at the steps. Right. It was in standard form. The original problem was we converted it to a 2x3 matrix. We put the matrix in the calculator. The next thing I'm going to do is return to the home screen. So I'm going to hit second and quit. All right, so second and quit. This is the home screen. Now from the home screen, this is where I'm going to actually calculate the solution. I need a little bit more space. All right, so the next thing we're going to do is calculate the solution. All right, so whenever you're trying to calculate the solution, you must put these things in on the home page. Right, so I return back to my home page. Now I'm going to go in the stats. Well, excuse me, I'm going to go back in the matrix. So that's second matrix. I'm going to go over to math. I'm going to scroll down till we see this RREF. This RREF is stand for reduced row echelon form. I'm just telling you what it means. This is what the calculator is using in the background to give you the answer. But there's two of them. It's a REF and it's a RREF. You want to make sure you hit RREF, reduced row echelon form. So I'm going to hit enter. And then now you have to tell the calculator which matrix you want to reduce. So I have to go back into the matrix. So the next step is going to enter the matrix. So I'm going to go back into the matrix. So that's second and matrix. All right, so now that I have RREF on my home screen, I'm now going to go back into the matrix. So I'm going to hit second matrix. I'm going to find matrix A. So we hit second matrix, and then we select matrix. And then I'm going to close off that little reduce echelon row function. and then I'm gonna hit enter. Okay. Is everyone who's following along, do you see an output that looks like this? Right. So from this, it doesn't really spit out like a nice answer. You have to pull the answer from this matrix. So just like we put it in, we're going to take them out the same way to get the answer. Okay, so this is how you decipher this. So just remember, when we put the matrix in, the first column was X, the second column was Y, the third column was equal. These are nothing more than the coefficients. So this first row is actually an equation. It's 1x plus 0y is equal to 3. So once all the dust settles on that, what is that actually saying? Well, 1 times x is x. 0 times anything is 0. So that would give me my first solution. X is equal to 3. So that's actually an equation. X is equal to 3. What is this second equation? Well, that's 0x let me do it like this. 1, 0, 3, and then 0, 1, 2. That's the same thing as x equal to 3. And that's the same thing as y equal to 2. So the solution is going to be what? 3, 2. All right. So we're pretty much going to use these same 5 steps. Is that 5 steps? Yeah. 1, 2, 3. I got awesome. We're going to use these same 6 steps to find the other solutions. All right. So any questions about the first one? All right. The second one is pretty much the same. It says solve the system of equations. If there's a single solution, put in a single solution. If there's infinite many solutions, we just want to write out the all real numbers format. So the first thing we're going to do is convert this system into a matrix. So our matrix is going to have how many rows and how many columns? Well, it looks like this is going to be a 1, 2, 3 rows. And then we have an X, Y, Z, and an equal column. So this should be a 3 by 4 matrix. So I'm following the steps from last time. So is it in standard form? Yeah, it's in standard form, right? All variables on one side, constants on the other. We're going to convert this one to a 3 by 4. Now I'm just going to put the matrix into the calculator. Right, so second matrix. From this point, you could use a different matrix. And there's like 10 of them to choose from, but I'm always going to pretty much stick with this first matrix. So I'm going to scroll over to edit. I'm going to hit enter. And I'm going to change up my dimensions, and notice just what happens. 3 by 4. The calculator output can only show you 3 columns at a time. There is a 4th column. If you right arrow over, you can see that 4th column. But if by default, it's only going to show you 3 rows at a time. So now we're going to take the system and we're going to put its coefficients into the calculator. So that's 2, 2, -1, 3, 3, 2. Okay, I put something in not right. 2, 2, -1, 1. -2, -2. So I think I got it all in. One way you can actually check, I'm just going to get out of this for a second. I can actually go back into the matrix. And from this point, under names, if I just select my matrix and hit enter, it'll kind of spit it out. So I'm just kind of double checking. It's 2, 2, -1, 1, 3, 3. Okay, so that looks good. 2, 2. This should be a +2. I think that's a +2. Let me just check this one more time. And one thing we're dealing with the calculator, make sure you got the right matrix in, because if you don't have the right matrix in, it's definitely going to give you not the right answer. Okay, so notice I kind of checked this thing about twice. So this looks good. 2, 2, 1, -3, 3, -2. Okay. So now I'm just going to clear that out. And if we go back to our steps, well, I guess we can't. Okay. All right, so at this point, we want to put the matrix into the calculator. Well, we've already put the matrix into the calculator. Now we're just calculating a solution. So I'm at my home screen. To calculate the solution, it's second matrix. I'm going to scroll over to math. And then I'm going to scroll to RREF. Then I'm going to enter in my matrix. I'm going to go back into the matrix, select matrix A, and I'm going to hit enter. Right. So is everybody getting this output, or is anybody seeing anything different? All right, so believe it or not, this over here is supposed to be the answer. Just one thing about this. If you have one solution, just as in the answer before, notice that when you read this out, it kind of, x is equal to 3, y is equal to 2. If your bottom row is all zeros, then it's an infinite solution answer. If your bottom row has all zeros and then there's some number at the end, This is a no solution. And this is the reason why. If we kind of take a look at this output, this says that x plus y is equal to 0. The second line on this says z, because remember x was the first, y was the second column, z was the third column. The second equation says z is equal to 0. But it's this very last equation. It says that 0 is equal to 1. 0 is never equal to 1. So this is a no solution. So the first thing you should do is when you pull out your RREF, if the bottom row is all zeros, it's an automatic infinite solution. If the bottom row is all zeros and then you have a 1 or some number on the end, that's going to be a no solution. So for the second example, this is a no, or excuse me, this third example, this 3 by 4, this is a no solution. All right, because the bottom row on our reduced echelon form gave us 0 is equal to 1. 0 can never equal to 1, so that's no solution. So that's like the only little caveat with the calculator is this bottom row. If it doesn't give you a straightforward equation with answers. All right, so that next one, well, the previous one was a no solution. All right, for the next example, I want to try to cover every example of what you may experience. And this example is one where there's usually a lot of problems. Because initially, when you first look at this, physically it appears to be a 3 by 3, right? Because we have 3 rows and I'm looking at 3 columns. But as you look at this a little bit more closely, notice that there's an X variable, there's a Y variable, there's a Z variable, and then there's an equal sign. So this would actually be a 3. We got 3 rows. Well, we're going to have 4 columns. If you're missing a variable, you substitute it with a 0. So here's what I mean by that. So this first equation is x plus y is equal to -6. So I have 1x, I have 1y, I have 0 z's, and it's set equal to -6. So that's what I'm going to put in my first row. If you're missing a variable, you want to substitute it with 0. The second equation is 0x plus 1y plus 1z is equal to -3. And then the last equation is 1x. There are no y's. Z is -1, and that's equal to -3. So this is what we're going to put into the calculator. So be careful. If you're missing a variable, you want to make sure you substitute it in with 0. And just notice for this particular problem, one of the variables zeroes out in each one of these equations. So that's why it appears to be a 3 by 3 upon first look, right? But once you see that there's an X, a Y, and a Z variable, we must account for those. So now we've written out the 3x4 matrix. I'm going to put it into the calculator. So second matrix. I'm going to edit matrix A. It's already a 3x4. -3. -1, -3. Okay, and let me check out the matrix. So it looks like I have everything in the correct way. So now I'm just going to calculate the solution. So I'm at my home screen. I'm go back into the matrix. I'm going to scroll over to math. Scroll to RREF. I'm going to put in matrix A. And this should be a what? If I look at my bottom row, it's all zeroed out. So all zeros indicate that this is all real numbers. So any questions about that example? Now, just knowing how to put a matrix into your calculator and calculate the solution, that is enough to pretty much cover the next two sections at least. All right, so in that first section, that was our introduction to matrices. We basically took systems, converted them to matrices, and popped them in the calculator, right? For the determinants of matrices, it says you're learning about determinants of matrices, specifically how to calculate them and understand their properties. The determinant of a 2x2 matrix, this is like the math, the hand written out formula. If you have a 2x2 matrix and you want to find the determinant, you would simply multiply A times D. You would multiply B times C, and you would subtract the two together. It says a determinant of n by n can be found by using a cofactor expansion. But since we have the calculator, we don't have to really do any of this stuff. The matrix, the determinants of matrices, they were used in a time when there was not a calculator you could just kind of dump these things into. When you solve a system of equations like we just did, we kind of put it in the calculator. But if you wanted to do that by hand, you would have to use determinants. You would have to use something called Kramer's rule. I don't even think that they even teach this stuff anymore. But just to show you what this stuff looks like. And it is really involved. Oops. All right, this is an example. You got a 3x4 matrix. You have to find the determinant. It's like a whole lot of stuff you got to do. And then finally you get the answer. Z was equal to 2. All right. So a lot of these things that we're seeing, they're kind of passe because of use of the calculator. So the determinants are used in solving system of equations. Because somebody asked me that before, and I kind of was telling the same thing I'm telling you. All right, so this says find the determinant. It's not going to be too hard to do this by hand. I mean, I could multiply these two right? -1 times -4 is 4. I can multiply these two 3 times -2 is -6. And then I can subtract the 2 and get 10, right? That was just what the formula did up here. Right, just multiply these two, multiply those two, and just subtract, right? That's what I did. If you're using the calculator, which I would really prefer for you to do, I'm simply going to enter this in the calculator as a 2x2 matrix. I'm going to put in the numbers. I'm going to go back to my home screen. Then I'm going to go back into the matrix. I'm going to go over to math. I'm going to go to DET, which is determinant. I'm going to tell the calculator which matrix I want to find the determinant of. And it's just going to give it to me. So I get 10. Any questions about this one? You can do it by hand by using a formula, or you can pop it in the calculator. So for a lot of these matrices in this section, we're pretty much going to pop them in the calculator, and we're going to go into this math section. Oops, where is it? Go into that matrix math section. And the only things we're going to be using here are pretty much the determinant and that RREF. All right, so that was the first example. Example number 2 is similar, right? They're asking us to find the determinant. This is a 3x3 matrix. If I go back up to the overview, it says a determinant of n by n can be used, or can be found by using a cofactor expansion. We're not going through that cofactor expansion. We're just going to put it in the calculator, because cofactor expansion would be about another 30 minutes. All right, so I'm going to put this in as a matrix. So I'm at my home screen. This thing has 3 rows and 3 columns. So again, I'm just going to edit matrix A, a 3x3. And I get 1. All right, so I did that kind of quick, but the determinant of this is going to be 1. Any questions on this? I basically put it in as a matrix, sort of the same RREF process we went through, but we didn't use that RREF function. We just used the determinant. All right, so for number 2, that should be 1. Don't worry about cofactor expansion. I would just put it in the calculator. The next section is matrices operations. And the thing about this is you can put the stuff in your calculator, but when you multiply, there's certain things, certain matrices you can and you cannot multiply. Okay, so this is, first we're talking about addition. So matrix addition involves adding corresponding elements of 2 matrices that have the same dimensions. So you can only add matrices that are exactly the same. They have to have the same number of rows and the same number of columns. And if they have the same number of rows and same number of columns, you would simply add the corresponding elements. And example number 1, they want us to do just that. They want us to add A plus B. So I can kind of do this manually first, just to show you. So I can just add corresponding elements. So 6 minus 3 is what? 3. -2 plus a -3 is -5. 4 plus a -3, 1. 6 plus 6, 12. Now I'm showing you the hand way because sometimes it's quicker to do it by hand than it is to kind of put all this stuff in calculator. But I'm going to show you. So here I'm going to put matrix A in as a 2 by 2. I'm going to put matrix B in as a 2 by 2, and then I'm just going to add them together. So I'm going to go back into my matrix. I'm going to edit matrix A. I'm going to go back into the matrix. This I'm going to edit matrix B because I got 2 matrices, so I'm going to use B. That's a 2 by 2. -3. So once you have your matrices in, I'm going to go back to my home screen, and then I'm simply going to recall matrix A. I'm simply going to recall matrix B and add them together. All right, so same thing we got by hand. Any questions about it? Okay, next there is something called scalar multiplication. And this means that if you have a number, a single number outside of your matrix, that's called a scalar. And to multiply your matrix by a scalar, you simply multiply every element in your matrix by that scalar. So for this example, we're given matrix B, and they want us to find -5B. So I'm basically going to just multiply every number in here by -5. So -6 times -5 is 30. I think that's -40. I think that's -40, -40, +30, and +40. Yeah, that's positive, negative, positive, 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 positive. So I think that should be it. But if I want to do it on the calculator, I would go into matrix. Since this says matrix B, I'm going to just go ahead and edit matrix B. Edit matrix B. This is a 3 by 2. 3 rows, 2 columns. So that's -6, 8, -8, -8, -6, -8. So now I got the matrix entered. I'm going to go back to my home screen. I'm simply going to multiply 5 times matrix B. I'm sorry, that should be -5 times matrix B. Okay. -5 times B. And there it is. I mean, so not too terribly hard by hand. So that's multiplying by a scalar. The next is to multiply 2 matrices. Okay, so this is where knowing what can and what can't be multiplied. This is a new matrix multiplication is a binary operation that produces a new matrix. For multiplication to be possible, the number of columns in the first matrix, so this is a 2 by 3, right? The number of columns in the first matrix must be equal to the number of rows in the second matrix. So my first matrix has 2 rows, 3 columns. My next matrix has 3 rows and 2 columns. It says that in order for multiplication to be possible, the number of columns in the first matrix, which is 3, must be equal to the number of rows in the second matrix. This gives me the dimensions of my output. So when I take a 2 by 3 and I multiply that by 3 by 2, I'm going to get a 2 by 2 matrix. So the number of columns in the first matrix has to be equal to the number of rows. If these two things are not the same, you cannot multiply. So I just want you to keep that in mind, because once you pop this stuff in your calculator, some of these things are going to give you like an error, and you may be wondering why. And the wondering why is because you can't multiply. All right, so just keep that in mind. All right, so this is example number 3, and we want to multiply the 2. It says use matrices below to perform the operation. So we want to multiply A times B. So matrix A is a 2 by 2. Matrix B is a 2 by 3. So once we multiply these things, our final matrix is going to be a 2 by 3. Now, when you're putting all this stuff in your calculator, you don't really have to do all of that. You just need to know if you put it in and it says that it's not an answer. If you get something crazy, then that just means that you can't multiply. So I'm going to put this first one in as matrix A. So I'm going to my matrix. I'm going to edit matrix A. It's a 2 by 2. -6. I'm going to go back into the matrix and I'm going to edit matrix B. It is a 2 by 3. -5, -5, -3. So I have matrix A and matrix B in, and then I'm just going to recall them and multiply. So that's A times B. So this is negative 20, 55, 7, negative 28, 62, and 6. So any questions about that one? Okay, and this is the last one. This is example number 4. It says use the matrices to perform the indicated operations. I'm just going to put in A and B in the calculator, and then I'm just going to square them. All of that in the calculator. So I'm going to put in matrix A. It is a 2 by 2. Five, 7, negative 5, negative 3. I'm going to put in matrix B. And it's a 2 by 2. And then I'm going to matrices multiplication is not commutative, which means that B squared times A squared is different from A squared times B squared. So make sure you put it in exactly like you see it. So I'm going to recall matrix B. I'm going to square that. Times, I'm going to recall matrix A. And I'm going to square that. It's like the calculator is doing most of the heavy lifting in this. What we need to be concerned is how to put the matrix in the calculator and how to interpret the answer. All right, so that's negative 610, 134, 170, and negative 30. So this last module is basically a calculator set. All right, any questions about matrices? Now, when we meet again, I believe there's only one more section here. So just taking a look ahead, the 27th, I believe that's the last day of class. So we will meet Monday. So on Monday, we will cover the last section that deals with system of linear inequalities, where you got to graph stuff. Next Wednesday, we'll do a final exam review. And then on that last day of class, on the 27th, we will probably be continuing that final exam. All right. Any questions about anything? We're nearing the end of the semester. So we basically have 3 more class periods. Next Monday, next Wednesday, and then that following Monday, the 27th, the last day of the semester. I'm sorry. I got so many. I'm sorry. Thank you for everybody listening. Next Wednesday, this is a Wednesday only. I got a Monday win. Okay. So next Wednesday, we will finish the last part of this. And then for the final exam review, I will start it in class. And if I don't finish, I'll kind of video it out and just post it. All right, any questions about anything before we dismiss? No further questions. See you all next week. And it's tax day too, so that's where my head is at.